Fog computing, when fog makes things easier to see. My name is Tom Luby. This video was prepared to complete a course requirement. Contents reflect my knowledge and view on the topic and do not reflect views of any other person or entity. By the end of this presentation, I can distinguish between cloud and fog computing, compare limitations and advantages of cloud versus fog computing, identify fog computing applications that may improve efficient and effective business information disaggregation, storage, and retrieval for safety, security, or expediency. Cloud computing. Cloud computing requires an inordinate amount of bandwidth to house all the elements. This includes the data that's collected and used, applications of the data, the platform of the big data management, and the infrastructure used to house all the services. More data equals more bandwidth, which lends to increased costs. All the components are linked directly to one central cloud. These components can include laptops, servers, desktops, tablets, and cell phones. The more items linked to the cloud means the more bandwidth that's being used, which can decrease speed. Security will be diminished as the data sums our externally linked devices increase. Fog computing. Fog computing is essentially the filter between externally linked devices and cloud computing. This layer between devices and the cloud is considered to be on the edge of the cloud. This makes them closer to the devices producing and accessing data. Fog computing disaggregates or breaks up the data and reduces the amount of transferred to the cloud. Less data transferred means the amount of bandwidth being used is decreased and efficiency is increased. Fog computing that is housed closer to the original source increases speed, single data hop, and mobility. These fog computing devices are called nodes. Efficient fog computing systems are designed with critical node placement in mind. Externally linked devices that are linked to the fog nodes will process information locally. Properly placed fog nodes will reduce connected devices, which leads to increased speed and security. Let's discuss the differences between fog and cloud computing, as well as what they both have in common. The commonalities are both systems will not lose data when an end device is damaged. They both allow for the data to be accessible from anywhere, and both can be used across multiple platforms. The cloud houses all applications, data transfers, and storage simultaneously across these platforms. Because of all the data being transferred, the speed is reduced in the cloud and is due to this increased bandwidth being used. Cloud-based systems require internet connectivity. Fog computing systems have increased security because of the data being housed closer to the device. Because this data is held closer, there is faster response for critical data. Fog computing has a reduced data processing burden, and also fog computing systems are able to go around the internet for faster, reliable computing. There are many cloud-based systems that would benefit greatly from using fog computing. Healthcare is one such example. The cloud expanded the use of wearable medical sensors. A cloud-based system is not appropriate for these sensors when emergent real-time data is needed, like cardiac or seizure data. Fog-based systems will help with real-time data and speed of transfer, so quick decisions are possible. The fog places healthcare systems on a separate log to help provide real-time data without fear of loss of connectivity. This significantly reduces latent data transfer issues. Another example of how fog computing can greatly benefit an information system is public safety. Fog computing can automate and monitor traffic systems for real-time information and alerts. Civil aviation creates mountains of data. Fog computing can better manipulate this data for safer plans and better efficiency in flight. Crime reduction is possible with fog technology as well. Immediate response to safety threats are possible with real-time data and the reduced latency of critical information. The future looks better in the fog. In summary, fog computing puts data on the edge of the cloud. It allows for real-time data with reduced latency, improves the security, data is proximally closer to the user, it's cost-effective, faster, has a myriad of uses, and is still evolving. It's the survivor who moves towards the edge of the dense cloud to stand in the fog, become faster, safer, and living longer. Start moving towards the fog. Thank you.